Welcome to FE Study Buddy Shorts, where we aim to solve an FE exam problem in 3 minutes or less. Try pausing now and attempting the problem yourself before continuing. In this mechanics and materials problem, we're asked to find the internal shear force at point B, which is located 4 feet away from a pin. We have a roller at point C and a point load at a 5-foot overhang of 10 kips. In between our two supports, we also have a line load of 2 kips per foot. To start, at point A, we're going to have a vertical reaction of AY and a horizontal reaction of AX. At our roller, we will have a vertical reaction of CY. Next, let's simplify our line load into its resultant acting in the middle. We have 2 kips per foot acting over 15 feet, giving a total of 30 kips. That'll be located 7.5 feet from the left and 7.5 feet from the right. Our next step, taking the sum of moments about support C, and anything going counterclockwise will cause a positive moment. Starting from the left, AX passes through support C, so it will cause no rotation. AY, which is going to cause a clockwise rotation about node C, and it is located 15 feet away. So we have negative AY times 15 feet. Next, our resultant, which is going to cause a counterclockwise rotation, and that has a distance of 7.5 feet away from joint C. So positive 15 kips times 7.5 feet. CY passes through our support, so it has no moment arm. And lastly, we have negative 10 kips, which is 5 feet away, causing a clockwise rotation around joint C. Plugging that into our calculator, we will find AY is equal to 11.67 kips. Next, we can take a section cut. So we're going to draw our beam, take a cut 4 feet away from support A. AY, we just found, was 11.67 kips. We did not find AX because we do not need it in this equation. We have our distributed load of 2 kips per foot. That resultant, again, will act in the middle of this 4-foot section. So we have 2 kips per foot acting over 4 feet, giving a total resultant of 8 kips. Using positive notation, for internal forces, we have VB going down, and counterclockwise, our moment at B. Next, using equilibrium equations again, we're going to do sum of forces in the y direction. Anything going upward will be considered positive. We have 11.67 kips from our AY, a negative 8 kips from that resultant, and a negative VB from our internal shear. That will all sum to 0. Plugging into our calculator, and we get VB is equal to 3.67 kips. The nearest answer is option A, 4 kips.